Okay, let me ask you something. Is there a tool or something you could use to help you visualize this problem?
All
right, so a picture. Yes, draw it. Super helpful. Absolutely. All right, well, mine's not very good and rectangular, but it will suffice. You guys know what that word means? It'll do.
Like that.
It'll do. All right, your rectangles look a little bit round, so let's get our right angles. All right, right angles. Yep, rectangle has 4 right angles. But what's missing?
It's not my fault. It's this. 7.
It doesn't have numbers on the side.
All right, it doesn't have what, Luke? Thank you. We do not know the sides. What? All right, hang on. Shh. You need a pen? What?
My fault.
All right, so Luke, you're telling me we don't know the sides. What we do know is the perimeter, right? 30 meters, all right? So,
Is that a goodie bag?
apparently for you guys, because you guys always show up asking for it.
Wait, is there any way I can eat my chips right now? Like
No.
any absolute way?
No.
Like, I lost my pencil.
No, but you guys leave all those crumbs on
I'll
the
pick 'em
floor.
up. If I
Ruins it for everybody.
If I do, I'll pick them up.
All right, no.
You get your crusty crumbs on floor.
They'll have to shelf it in, okay?
Just use it, please.
Raisins.
I am so sorry. Finally, you got me answer. What's your answer?
I know it.
All right, here's my question. I've heard at least 3 people say, Liam, are those color pencils? Can you do that later?
No.
Can you do that later, please?
Oh.
I had 3 people say, I have the answer, and I'm going to push back. How do you know it's the answer?
Look at them.
Because I know.
Okay, hang on. You're not reading into my words. Okay? How do you know it's the answer and not an answer?
An answer.
The perimeter is the whole thing.
Noel, give me yours first, then I'll get Luke's, and we'll see.
7.5.
What's 7.5?
What? 7.5 plus 7.5 plus 7.5.
Okay, so you're saying that all 4 sides, all 4 sides equals 7.5. Okay, and you just gave me the math. 7.5 times 4 is 30.
But they're different rings.
Luke, did you get that? What'd you get?
I put
On the side,
Option 2.
on the side, I put 3, and on the top and the bottom, I put 12.
So how would you test to see if that's right before I get Cora's answers?
12 plus 12 is 24, and 3 plus 3 is 6, and 24 plus 6 is 30.
Oops. Okay. Cora, what'd you get?
10 on the
Width equals 10. Length equals 5. And how would you prove that yours works?
10 plus 10 plus 10. That's what I was going to say.
But when you add 2 things that are the same, can we not just say 2 times 10 and 2 times 5? Like that?
Yeah.
Liam, you got one?
Yeah.
What'd you get?
Length is 9, width is 6.
Length is 9, width is 6. Okay. 4. We have length is 9, width is 6. And we could say 2 times 9 because there's 2 widths or 2 lengths. And then 2 times 6, 18 plus 12. Is that 30? All right. So you're thinking, wait a minute. That's why he said you have an answer, not the answer. Well, that's because there's not one answer for this problem. You see, I set it up in such a way so that it's any rectangle with a perimeter of 30. And you guys all fell into my trap of actually starting less than 89, or whatever, at less than 90 early. So,
You started out only?
I got you. No, but really, what do we need to do? What can we do to represent a way to relate L, W,
2 and 14.
and P for a rectangle? Is there a, wait for it, formula that we need to be able to use? Perimeter of a rectangle. How do you find it? You look at what we did here. I tried to give you some hints. You guys gave me widths and lengths, didn't you?
Yes.
But what did we end up doing with those to solve or set it equal to the perimeter of 30?
Multiplying them by 2.
So what would that look like? How do you what if I say take the length and multiply by 2? What do I write?
The 12 times 2.
Any length, not just 12.
462 million times.
No, that's just another example. For it to be any length, a value that is able to vary, I have to use
Division.
a variable. See what I did there? 2L plus. Why do we add? Because perimeter is the sum of all the sides distances. And how do I say twice the width? What do I write?
2
Hey, you're figuring it out now.
2 width.
All right. So all we've got to do is think about, that's the perimeter formula for a rectangle, right? Yeah, it is. So lesson 90, maybe that's actually 91. So we'll go backwards. We'll do lesson 91 first. All right, so for lesson 91, right, the topic name, they just call it geometric formulas, okay? And I know I've been talking to you about flashcards on purpose over and over. You guys should probably start doing that, okay? But none of the answers that I got are wrong. Okay, so Luke, Noel, Cora, Liam, you're all correct. You're all correct with the values that you gave me. But sometimes there's not always more than one answer, okay? So there's a few formulas that we need to know. The first one that is a review, should be, is the area of a rectangle. I'm just going to make a little category here. Rectangle. How do you find the area? Yeah. Whoa. First two parts. Length times width. If you add in the height, then it becomes volume. But we're just talking about area. Okay? What about perimeter? I just gave it to you. It's 2L plus 2W. Now look, I know you could, if you had the picture, you could just add the sides in order, and that would be fine. But this is a more efficient way to do it. You guys know what I mean by efficient? Sphere?
Easier.
No, not always.
Convenient. Easy.
Sort of. It's not easier sometimes. A lot of times it's not easier because it's something you have to learn that's new, that in many cases is harder. Grayson?
Fast and right.
Can you answer what efficient is? Here's an example. To be more efficient in your classroom activity would be to spend the bathroom trip during class change.
To do less work.
Sort of.
To do less, to not do
More work in less time.
Bye. That's what I said.
Is it?
Yeah, I said less.
All right, Grayson. Go ahead. All right. So what about a square? How do we find the area of a square? But since it's a square, they're the same. So what do we write?
L times L.
No.
Yeah, we could do that. We could do L times L. I'm going to use S, but instead of saying S times S, because they're the same, I'm going to use laws of exponents to write it as S squared. What about the perimeter of a square? They're all the same still, right? So instead of saying S plus S plus S plus S, what could I write?
S times 4.
S times 4, good.
S to the 4th power.
No, that is not the same.
That's way too much.
That would be multiplying. S times
yeah.
S times S. Okay. All right.
So it'll be
I guess we'll just do one more. We'll do the triangle. Triangle's area formula. What is it?
Base,
Times height.
base times.
Oh yeah, base
Divided by 2.
Base times.
Yeah. All right. 1/2 base times height. If you want to say base times height divided by 2, it's the same thing. Okay? All right. So, what about perimeter for a triangle? And I'm not telling you anything about what kind of triangle it is. It's not special in any way. We don't really have names for the sides of triangles. So here's what we're going to do. We're just going to write S1 plus S2 plus S3 plus anything else? Why not? It's a triangle that only has 3 sides. Good. Okay, the fact that I wrote S1, S2, and S3, what does that imply about the lengths of the sides?
It's 3 different.
It's 3 different ones, possibly. We're not assuming that any 2 are the same, and that's why we chose S1, S2, and S3. Okay? All right. Parallelogram is on the table on page 489, but we'll come back to that. So, here's what I want you to do for lesson 91. Oops, a whole bunch of videos there. I'll come back to it. I'm sorry. I should probably take attendance today. You're all here.
The president. Except for a person that I think used to sit beside you.
That would.
Everybody's here.
Pippa. That's right.
Girl behind.
That was a long time ago. All right. So, let me make sure I don't take away. Let's see. No, of course we can do that. All right. So, you said you needed another minute to finish writing them.
I finished it.
All right, so here's what I want you to do. I want you to do the practice set. Let's see if I've given you enough information already to do the practice set. I'm going to go ahead and give you the formula for the perimeter of a parallelogram. It's 2b plus 2h. Oh, wait a minute. Sorry. That's an S. Sure. That's an S. Not a 25, but an S. So that's for part B. So I want you guys to try A and B. All right. So look, guys, all it's asking us to do, write the formula for the area of a rectangle. You should be able to tell me that is A equals L times W. Substitute 8. 8 for the length, 5 for the width. Get 40. What are the units of my answer? Centimeters squared. Okay, guys? We are going to have at least one more test in here, so I suggest you continue to pay attention. Write the formula for the perimeter of a parallelogram. Then substitute 10 for the base and 6 for the side. So P equals 2 times 10 plus 2 times 6. So we're going to substitute that in. You can kind of see where I'm doing that here. 6 for the side here. And then the final answer, 20 plus 12, 32 centimeters. Now this might not seem like we're doing a whole lot. It might actually seem like it's nothing new. And to be honest, if you're just focusing on the answer, you're right. It's not. I didn't give you a picture though. If you think about that, without a picture, you're having to find some geometric answers. Okay? It doesn't mean you can't draw a picture. In fact, it's probably a good idea for most everybody. But the idea here for lesson 91 is that you are taking a formula, and here's the important word for the entire lesson. What do you guys see with that word? How do you interpret that word?
Switch. Replace.
Switch, replace. Excellent synonyms. I like it, right? So if I'm not here one day,
Destroy.
you typically get a substitute, right? Someone who stands in place for me.
Is it as good as you? Destroy. Unless it's Miss Dempsey.
Ah,
Then y'all are like equal.
got it. So, that's the big idea here, guys, is that we're learning how to substitute in to a formula, okay? 8 centimeters for the length. You can kind of see it right there. I replace it. So to substitute means everywhere you see a particular letter, you replace it with the substitute value. Okay? So let me give you one extension in your notebook, okay? One more extension in your notebook. All right, so yes, you got to write all of this down. Find the value of AB plus 3C if A equals 2, B equals 7, and C equals 4. I won't give you any negative numbers. That might not be the right thing to do just yet. So this is a connection to lesson 91. No, doesn't have to do with a shape. But it does have to do with the idea of substituting in a value. Okay?
OT.
So, find the value of AB plus 3C if A equals 2, B equals 7, and C equals 4. This is technically a skill from Algebra Half. Okay? For those of you planning to take that next year, not everybody, but you'll see it next year or the next. Nonetheless, it's exactly the same as what you just did for the perimeter of the parallelogram, for the area of the rectangle. It's exactly the same. Okay? It just has more letters and less of a physical shape to be represented with. So, here's what it means. Everywhere you see an A, we're going to substitute 2. Everywhere you see a B, we're going to substitute 7. And everywhere you see a C, a 4. Now watch. What does it look like when I do that? A is 2, and B is 7. Okay? Plus 3 times C, which is 4. Now what'd you say, Noel? 26. Let's see. How'd you get that?
Yeah,
You look at what I have.
2 times 7 is 14 plus 3 times 4 is
14 plus 12. Now, 26 is a number. We could also call it a value, right? Sophia, Autumn, you're going to be okay? Or do I need to move y'all?
You need to move them.
It's looking like that.
Yeah.
Last chance.
No.
Okay? 26 is the value when. I'm going to use a different word. When A is 2, B is 7, and C is 4. Now, this number could change if I gave you different values for A, B, and C, couldn't it?
Yeah.
Okay. But this is the next year skill that is related to what we're doing in lesson 91.
All algebra has this? 'Cause that's
No,
easy.
that's not all. Tiny little bit, okay? But these are stepping stones to that skill. And that's what lesson 91 in your 6th grade book is trying to get you to do. Okay, so any questions about anything on this page, with rectangles, squares, you're going to see some of those problems on the homework, okay? All right, moving forward, or in this case, backwards to lesson 90. What is lesson 90 about? So I would recommend just starting a new page. New page. Lesson 90 is about getting turned. Sorry, measuring turns. So, I used to always make analogies to like basketball and dunks, but we'll do something different because suppose, let me use a different color. Suppose, who do we want to go take a walk here? Let's
Me.
see. Okay. Suppose Ella was walking. What direction do you want Ella to go?
North.
South.
North. Upwards. Into the sky.
Okay, that's not north, by the way. She then
Upward.
turned.
Left.
All right, I'm going to make this really hard. Just not really hard. Just 270 degrees
Oh my god.
clockwise. What
She almost did 360.
direction? That's true. Is she now
Going?
walking? Yeah.
360 is all the way around.
All right. So I like where this is headed. You guys are already basing this on what you know. That a 360, she did a 360. She'd be going the same
A
direction, right?
280 is halfway around.
West,
No,
south,
that's 180.
180.
East, and you said west. Any other guesses? What do we know that it is not?
Southwest.
Not south?
It's not.
It's
Let's answer this one.
It's
Yeah, go ahead,
not-
go now. Go ahead.
It's not.
I think it's southwest.
Not north?
It's gonna be northwest or west? I mean, wait, southwest.
All right. I hear lots of guesses, and I'm excited that you're already picking up on that. But let me ask you something. How far is each direction from the next one over?
90 degrees.
90 degrees?
Oh, northwest.
Going once?
So she'll then turn 3 different directions. Northeast.
What should we do to help us?
No, just east.
What can we
It's east.
write to help us? I can draw it, can I? I can draw it. So let's do. Here's Ella.
Hey guys.
It's abstract art. Okay. Here's Ella, and which way south?
Down.
Soggy.
Never eat soggy waffles.
Why not? They're good with syrup. All right.
No.
Why don't we just learn north, south, east, west?
Never eat soggy worms.
True. I would stay away from soggy worms.
Yeah, but
Although I don't know that they're any worse than crunchy ones. All right. So here's Ella walking south.
That's me.
270 degrees clockwise. Is it important that I put CW there?
Yes.
yes,
Is there another option than clockwise?
No.
there is.
All right, what is it, Macy?
Counterclockwise.
Counterclockwise, which means not clockwise, the opposite. So we think, oh, I didn't really pay attention when we learned how to read a
The
clock.
way that the clock doesn't go.
All right,
I never learned how to read clock.
I didn't either.
okay.
I forgot. Who denied?
Here's what I'm going to do, guys. I'm going to go ahead and draw all 4 directions here, okay? Now, it's really important that you pick up on the fact that these are, what is a relationship when they intersect in a certain way? Intersect perpendicularly.
I knew that.
What's important about that? What's the number that we associate with the word perpendicular? That's vertical.
Like this.
What's the number that we associate with the word perpendicular? 90. And you guys already said that, but I just asked it in a different way. You see, if this is south, and we have north, west, and east, you realize they're how far apart from each other? 90 degrees. Okay? So an angle measures an amount of rotation. It does not measure a distance, but it measures how much rotation is there. So this is a 90-degree angle, and this is a 90-degree angle, and so is this, and so is this. So for kind of a baseline of understanding, if she did a 360, she'd still be going south, correct?
Yes.
All right, but it says 270 degrees clockwise. So we have to think, okay, clockwise is the same way the clock goes. And you can look at my seconds hand as it is going, and you get a nice little picture of that. So if you're taking a test and you have to look up there, I'll know what that's for. Maybe it won't be there. Oh, it'll probably be there. Okay? But all that to say this. She's going south, and then let's rotate clockwise. How far is that? 90 more or 180? 90 plus 90 plus 90 is 270. So she ends up going east. Is it that easy? Is that all we're doing? Sort of.
That's what I say.
Okay. So, a couple things to keep in mind. There's 2 different directions of rotation. Clockwise,
And
counterclockwise. Not clockwise. Opposite clockwise, okay?
east.
an entire circle would be how many degrees of rotation? 360. That's going to be really important for the next several years, okay? But if we take one more stab at it, all right? So let's say if that was example 1, 90.2. Grayson's going for a walk now. Grayson's running. Runs west. Then gets disoriented. Let's say he got dizzy because he fell and he choked on the sucker that he's always eating. Disoriented. I mean, you do always have a sucker, right? Disoriented and rotates
Oh, suckles.
900 degrees counterclockwise.
That literally goes against everything you just said.
What direction would he be going? Would he be going?
Would he be going?
Wait, what degree?
900. Oh. Now, in 6th grade, you're not going to see a question on 900 degrees. You will see 270, 180, 360.
900 degrees.
But I'm just deciding to just go for it and say 900 degrees.
380 minus 100 is 380.
What?
Yeah.
Why are you challenging us with this?
I think you
I
can
got
do
it.
it.
Who's,
You guys,
who's George?
Going in.
this is Grayson, not George.
Who's George?
How does that say George?
I know it's like Grayson.
What should we do? Did it help to draw it last time? Yeah. Okay, so let's draw it. All right, so let's say he's going west.
George.
Okay? And let's have kind of a center for reference. Right? A pivot foot, if you will, basketball players.
It's what?
Disoriented.
What do you mean disoriented?
He hit his head on a tree and the sucker knocked him out. All right.
I don't know what's most. You or history?
Are the suckers?
History.
All right, anyways.
History.
Why is this not as easy as the last one? 900 degrees.
Such a big beast.
It's more than 360.
It's what? It's more than 360? Okay. Is there a way we could use our understanding of, well, there's 360 in part of it.
East.
Could we do that? Could we say, okay, if I go around one time, that's how much?
360.
And then if I go around again, oh, wait, what? 720. Okay. Wait. How much is left from 720 to get to 900?
East.
And there's the 180 degrees left
East.
He's doing something.
It's east. So,
east.
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 Wait.
I'm not going to two spins.
He did 2 whole spins.
Should I go on a wall?
You did 3.
No, that was 2 and then a half.
You said that one.
Woo!
That was 3.
That was 2. Ready?
That was 3.
Let's do it again.
You're so nice.
1, 2, and a half.
But you
Why
did
do you
2
do
and
it
then
to
to
B,
B.
but not to Ella?
Yeah, you did. I saw it. Well,
Who's
who's
better,
better,
Gracie?
Gracie? 360, 360.
You don't have a sucker now, so that's positive.
Can I go on a wall?
All right, so
Wait, what do you do? I want to go on a wall.
well, let's see what do your practice set problems look like, okay?
Wait, I'm not done. Jeez, calm down.
Let me go on the wall.
Am I making any sense here with lesson 90?
No.
All right, well, let's look at Tammy and Rob and David. That's the practice set problems, by the way.
This is a plus 180.
Yeah, it does. So 360 here, 360 more gave me the 720, and then 180 more gave me the 900.
Oh, hold on.
Sorry, it's really unclear. when I write like a chicken.
You do like right like a chicken. I don't think you're right.
All right,
Okay.
you caught up? All right, so A, B, and C, that's your practice for right now.
So smart.
Let me give you guys a few minutes to try these.
I'm not.
Bring your paper up here. Let's see what you got.
So I didn't write it, but I just like
Write it on the whiteboard for us. I'll pause the video.
okay.